SwayamPrabha. Digital India. Educated India.
Okay. So, now the next question is, what is chemical reaction engineering? Chemical reaction, okay, we will abbreviate. Yeah, this is a wonderful question. Do you have any definition for this? What is chemical reaction engineering? That is what is chemical reaction engineering. Huh? Yeah, okay. I mean, because some of these things we know, okay, but we do not know how to explain, right? That is exactly like love, right? So, similarly, chemical reaction engineering, it is not so bad, but the definition itself is in the title, chemical reaction engineering. Okay, you are engineering the chemical reactions. That is what is the good definition. But again, unless you do not know what you mean by engineering, you cannot explain further. Okay? And I do not know, some of you would have seen, there are many books, new books coming in chemical reaction engineering. One of the books, I think by Schmidt, SCHMIDT. What is the title of that book? You have seen that book? What is the title of that book? Engineering of the chemical reactions. Yeah, excellent. That is engineering of chemical reactions. And really, that is what is the true meaning. And I really appreciate the name itself, who suggested. Do you know who suggested that name? In fact, that is one of the latest names in chemical engineering. By the way, unit operations, who suggested the name? Yeah, it is Arthur D. Little, that you should know. I think you have to make a note of that. This is Arthur D. Little. After giving the definition, Little has become really big, Arthur D. Little. But before him, there was another person called G. E. Davis. Okay, this Arthur D. Little, can you guess which country? France. Don't know, but how do you know the name? In memory, you search it and then got it. He is from US. Actually, the idea came from Davis, where this Davis was in UK. When was that? In 1860s, 70s. So, he was a factory inspector. Actually, he was the first person who gave a course in chemical engineering. Okay, that was I think 1897, 1895 at that time, 18. Okay. So, at that time, when he was a factory inspector, even at that time there was a lot of pollution, particularly from sulfuric acid industries, chlor-alkali industries. A lot of chlorine is just used to come, lots of sulfur dioxide just used to come. So, that is why UK government appointed him as a factory inspector, where he has to visit all these factories and then try to find out how to reduce the pollution. So, when he went and visited various industries, he found something common among all these industries. Whatever industry he goes, there was fluid flow, right? Whatever industry he goes, he saw heat exchange. That means different forms of, even condensation is a kind of heat exchange, and normal heat exchangers. So, all kinds of heat exchange equipment, right? And he also saw distillation columns. But without knowing all that names, they were doing the distillation, they know, but I think that unit operations name was not there at that time. So, he recorded all that. Now, instead of teaching, before that, how they were teaching chemical engineering was by industry wise. Take chloro, that means chemical technology, pure chemical technology was at that time. You take one industry like chlor-alkali industry and then discuss in that the various chemicals, what is the production method, what are the temperatures, what are the pressures, like our chemical technology they used to discuss, okay, in applied chemistry departments. Chemical engineering departments also were not there at that time. I am talking about 1800s, 70s, 80s, 90s at that time. So, then he said that there are many common operations, and that common operations are he listed them, and he gave a course, I think 12 lectures I want to get the original lectures, but I am not able to get the original lectures. And he taught them saying that okay, now instead of telling about particular industry, particular chemical, now let me talk about general operations like about fluid flow. And materials of construction was very seriously taken. When we were doing our BTech, materials of construction 1 or 2 courses we had. Ranganathan, you also had? Yeah, but now that has gone. I do not know whether you have taken materials of construction. And plant utilities, there was a course. And some universities still follow, very old universities still follow that, plant utilities, and there was 1 or 2 courses on plant utilities. Okay. So, he gave that course, and then US people came to know that okay, in UK this kind of teaching is going on. Then Arthur D. Little found out that let us give a name for these common operations, and he said unit operations. What a wonderful name. Okay. So, now under unit operations you have distillation, extraction, crystallization, I mean of course heat transfer, all these operations will come. Then beautifully McCabe and Smith used that title as it is, unit operations in chemical engineering. That is the title of the book. No? Yeah. Similarly, in 1957, that was very late in fact, chemical engineering is almost established a little bit, but still chemical reaction engineering was not established. 57, there was a conference in Netherlands where the title of that conference was chemical reaction engineering, and they wanted to concentrate only on reactions. And in a unit operations all the focus is on separation or mass transfer, heat transfer, that kind of thing. There is no chemical change, only physical change. So, that is why all unit operations deal with physical changes. Then they wanted to know, but can you also have a separate course on reactions? Till then reactions were not very seriously taken. They do not know how to find out, for example, kinetics, but approximately they know that this is the temperature, this is the pressure. That is why applied chemists, that exploratory research I told you, exploratory research is by trial and error. So, through that they know this reaction will have this kind of temperature, this kind of pressures, this kind of equipment we can use, all that they have fixed it. But it was not a science, or it was not even engineering. I will also tell you what is the difference of the science and engineering, right. So, at that time the name of that person was J.C. Flugter, Flugter. Not, I mean, we in Europe that V is called as FOW, F. Okay, Flugter, I think, yeah, J.C. Flugter, Vlugter. Yeah, he was the person who gave this name for chemical reaction engineering for that conference. And they wanted to discuss in that conference, as Gani said, Abdul was telling that all the things, how do you design the reactors, what is the information required for reactors. So, all that proceedings, that first conference proceedings is okay, had been published in Chemical Engineering Science 1958 edition. In 1958, there are many issues, maybe I think some 8 or 6 issues or so. I think I am not talking, I am talking only in English. No, there is a journal called Chemical Engineering Science that started I think in 1953. That is the first volume. No, or 51, 53 is third volume. Yeah, okay. So, 1951 it started. Okay, this Chemical Engineering Science. So, in 1958 volume, because per year we will put all the issues in one place and then we call that is volume, 1958 volume. Complete all the papers that have been published in that conference or discussed in that conference, they are there in this volume, and the 1958 volume is available in our library also. Now, online also is available. Simply go to Science Direct and then open Chemical Engineering Science, go to 1958. I think if I am right, maybe June edition or July edition, I am not very sure, but you can check it. Okay. Yeah. So, there he has given that name. What a wonderful name. You are engineering the chemical reactions. What do you mean by engineering chemical reactions? For this you should know the difference between what is science, what is engineering, and what is the next one? Technology. These are the words very frequently we use without knowing. I will tell you another nice thing. When you want to join for engineering, what is the examination you write? Some entrance exam, maybe JEE or maybe every state has their own set, K set means Kerala set, and I think M set, and I think in here T set, tan set. So all sets only, but different examinations are there. So what are the subjects you choose for that examination if you want to become engineer? Maths, physics, chemistry, right? So once you pass or once you get good rank in that, then where do you go for engineering? You go to some engineering, right? And at the end, what is the degree you get? Did you read your degree? Bachelor of Technology. Did you ever thought what is the connection? What is this here? We have written only entrance examination as maths, physics, chemistry. Then someone told that okay, you join chemical engineering or mechanical engineering or civil engineering. Then at the end we are getting only Bachelor of Technology. Where is the connection? I say? Do you know the connection? Even after M.Tech, do you know the connection? Forget about B.Tech. You never thought about that, no? Fundamental questions, I say. You should question all this yourself, that why I am here. So why I was born only to these parents? Why not to Ambani's or someone else? Okay, so then very happy, no? Always flying and beautiful houses. You don't have to do anything. Okay, or take over your father's business, and already you are rich. You don't know where to keep your money. You can sleep on currency, eat currency, sleep currency. So all beautiful things, no? But anyway, it's unfortunate, Okay, good. Anyway, we don't have choice, but we are happy what we are. So that is the kind of basic questions, I don't know any one of you thought about that, or if you thought, just raise your hand. It is very good. You thought about that? What is it? What time? Now or earlier? Before. Okay. Yeah, that is very good. That kind of thinking is required, right? Then what is the difference? Anyone has been exposed to what is the connection or what is the definition of science, engineering and technology? Some teachers would have told you. People like me, I think there are people talk about many things, okay, and which is important. It's not that I have a beautiful quotation. I think they write that an excellent teacher not only teaches the subject, but he teaches an approach to it. If you want to get that approach to a particular subject, you need many general things, otherwise you never see the approach. I could have finished 50% of the syllabus by the last 2 weeks if I started straight away, okay, first order reaction, second order reaction, third order reaction. But no, I think you need this kind of background, you need this kind of seeds in your mind, that is mind clearing. In fact, before putting some other data, if there is useless data, you delete all the data, no, cleaning. So all the wires, should be cleaned, our hard disk. That is what the thing which I am trying to do now. I am trying to clean your hard disk. Except chemical engineering knowledge, there should not be any other thing in the mind. Okay, so that is why one of the definitions given is application of science is engineering and application of engineering is technology. But if I ask you explain, again you cannot explain. Correct, no? Yeah. Shall I write that as application of science is, again small abbreviation, engineering, and application of engineering is technology. Okay. In fact, technology is the highest form, but unfortunately without knowing any engineering, without knowing any science, you can become a technologist. How? Yeah, we have been doing, I think humans race started doing for long time. Okay, they constructed beautiful forts, beautiful houses, beautiful temples, beautiful all beautiful churches or mosques. I think wonderfully they have done without having a engineering degree, civil engineering degree, right? So they are the people who are technologists. How do they know? Feel. And we also know medicine in villages, and also of course everything was village only long time back. So in villages there will be a doctor, and he will know. Some of you developed that kind of knowledge, but there were no MBBS at that time, there was no MS, okay, but still they could. And I will also tell you, how do you produce bricks? Okay, before going to bricks, how do you produce curd? in your house? Okay, your mother knows very well, right? What does she do? Yeah, but no, suddenly she will not take, no, first step is not taking curd and putting where? Boiling. In the mouth or somewhere, yeah. Yeah, the first thing is to find out where is the milk. Take the milk and boil it. Why should you boil? Everything is a question. Yeah, why should you boil?
Pasteurization.
Then yeah?
Pasteurization.
What?
Pasteurization.
What is pasteurization?
To
Yeah.
kill the
To
microorganisms.
kill some other microorganisms which should not destroy the curd making microorganisms. So that is the reason we boil, and then after boiling she knows. I think now always whistles, no, in always now kitchens only whistles have come. First whistle, second whistle, third whistle. Okay, because of the pressure cookers and all that, right? Yeah, all whistling only. Cooking means no whistling. So anyway, I think she knows when she has to stop that boiling. Then what she will do? Immediately we add.
Cool
Yeah,
it.
yeah. Why you can't add immediately? Because microorganisms will die. They cannot take, like asking, putting someone coming and putting us in a furnace at 100 degrees centigrade. That's all, we are out. Okay. Yeah. So similarly, when you boil and then immediately put the microorganism, they will die. So that's why she cools. It is not sudden cooling. She will not use brine with -5 degrees and then suddenly cools. She will wait patiently, and then every time she goes and touches the surface of that container, and when she touches, she knows what is the temperature, right temperature. At that time she puts yesterday's curd or yesterday's buttermilk where there are microorganisms. Okay, and then her duty is over. Now it is microorganisms duty, right? Then after maybe 6 hours, 7 hours, 8 hours, you will get beautiful curd. We know how to eat curd, but I think how much technology is there inside, because without having any degree, she does not know what is biochemistry. Mothers. Okay, yeah, she does not know what is heat transfer. Still she boils, right? She boils at what temperature? She never measures the temperature. Correct? No, she never measures the temperature. So she knows that when it is coming, that the milk will come up with a lot of foam and all that. So once or twice she will say and then switch off. Then she waits. So like that, generally she may try to stir a little bit in between, but that is also not required for liquid, right? Even sambar making, they will stir and all that. So actually mother is an excellent technologist. Really, without knowing anything, she can cook food. And I told last time also, mother's food is the food lifelong you can eat. But if you go to Tiffany's, 2 days maximum. Okay. Okay. Third day you will say that go to hell, we will go to some other house. Okay, some other place. That's all. You see the appreciation for the mother. So that is the kind of technology what she developed. Okay, now technologist is one who knows how to make things by finding out some right conditions, maybe temperature, maybe pressure. I am talking about our chemical technologies. We have chemical technology, for example, fertilizer technology, rubber technology, polymer technology, cement technology, right? All these things have been done even when there is no chemical engineering. How they are doing? By trial and error. Maybe 50 years, 60 years, 70 years they could have spent time to come to those points, and then after you stabilize for those conditions, then transfer of knowledge is very easy. You train him to maintain these conditions, and next person will come, he will train other people. So like that it goes. That is what is the technology which we think is the lowest, but that is not correct, right? Yeah. So that is one thing. Even brick also. Brick, how do they make bricks? Because most of you are only born in cities, you may not know. I think you would have never seen also brick kiln, I think, how they make. But if you go to village sides or suburbans of any cities, you will see a lot of brick kilns. They take mud, and they do not take whatever mud is available. They will take mud with some sand, clay, with some percentage of solids. That is also very important, but they never measure. But they feel the moment they take mud into hand, they will tell that whether it is a good brick or bad brick. It will become a good brick or bad brick. Okay. And then they will put sufficient amount of water. Then they will make it as a paste. How do they make it as a paste? With legs most of the time. That is the technology. Actually these are the mixers, correct? No, like this, like this, like this, like this, you do all the time. Okay. So then they mix it and then they know the right consistency. They won't put more water, they also will not put less water. Less water also is difficult, more water also is right amount. Then they take the molds, big molds, then they just paste it, just pour it and then make level and then remove it. But again that leveling is not that all of us cannot do. They know how much pressure they have to correctly apply for that mold on the surface of that mold. Otherwise you will not get again right brick, the strength will not be there. So then what you do? Drying. The drying, natural drying, so solar drying, right? After solar drying then if you use the brick, then again if rain comes it will dissolve. So that is why they have to sinter it. That sintering is done in kilns. Then you will have the strength, the bond between all those particles, mud, all that becomes very, very strong. Okay? But where is engineering and where is technology here? I mean where is science here? And when a mother does this curd, what science she is using, what engineering she is using? Now I will ask a question. Mother does, what is the scale? Scale of her production of this one curd? 1 liter. Maximum 1 liter. Or if some guests come, maybe maximum 3 liters, 4 liters she can go. Now ask her to try 100 liters. Impossible, she will run away. That is where chemistry stops. I told you, then engineering starts. Okay? Yeah, I mean not exactly chemistry there I am telling. That is where, because scale up, because now we are talking about large scale. Now we have 8,000 students in the hostel, not even 8,000, I think 7,400 students. Now we want to make curd for 7,400 students. How do you make it? As a chemical engineer, what do you do? And you know that every student will eat maybe 300 ml of curd. 300 ml is too much. Okay, 100 ml. 100 ml of curd. And I do not know, many North Indians may not use the curd, but South Indians end point is only curd. After curd only they stop eating, till then they keep on eating. Either curd or buttermilk. And recently I went to some tour to Leh and Ladakh and that area. So I think in North India, I think from Delhi onwards, early morning they start with the curd. Okay, many people, they have aloo paratha. Aloo paratha, then we asked, so, okay, how do you eat? I mean, what is the other side dish for this? They say achar. I did not know what was achar. Achar was pickles. Yeah, I mean, mouth watering, it's good, very tasty. Yeah, so this achar with curd, what a wonderful taste, I say. It's a wonderful taste, I tell you. It's very good taste, I liked it. But unfortunately, this side we cannot make that kind of beautiful aloo paratha, right? But problem is, I can guarantee that health will be spoiled in 2 to 3 years. Okay? So if you eat every day that, yeah, because achar is very bad, because there are tons and tons of sugar, salt. Salt is always bad for the thing. And then of course they also put lot of oil to make aloo paratha. And curd also is bad. I think actually curd is not required for human beings, I tell you. Okay? It is not required at all. I have separate theory, when I have separate time we will discuss about that particular thing. So anyway, so the curd is the last point. We know 100 ml per each one, and 8,000, 7,000 students, and approximately you can calculate. And now that much milk you have to boil. How do you boil? Now engineering comes. First of all, you have to take a big vessels. Okay, you can also make a choice whether it is continuous boiling or it is batch boiling. Okay. Food normally, continuous food cooking, I think some 15-20 years back I thought, why can't we have a continuous rice cooker? That means you feed at one point rice and other point you should have, this is grains and that is cooked food. Okay? But there was a lot of, it is not that easy to do that. Why? Because I have to maintain very clear plug flow. That I will discuss later, what is plug flow and all that. So that is why either continuous system or batch system. That is why most of the time in all cookings you go for batch. What a wonderful concept. Without knowing what is plug flow, they used batch cooking. In batch cooking, every particle will stay exactly same time, because you are not allowing, no? You are allowing 10 minutes cooking means 10 minutes all the particles are there. So uniformly cooked. if you allow them to go flow, there may be small particles which may come faster, there may be large particle, uniform rise you never get. Even the best basmati you take, I think nowadays I think basmati is coming almost 1 inch long, I say. I think I don't know how do you put it inside. So that one when it is flowing, shape factor is very bad. The flow, fluid mechanics I think will not have that kind of nice flow for these kind of particles. Okay. Anyway, so then either batch or continuous you have to choose, and you cannot simply boil it because there is a large amount of milk in that vessel, and when you boil, which part of the vessel will get first heat? Bottom and sides also, if it is metal. Okay. So then when you are boiling this, then the top liquid will not get sufficient heat, right. So then if you are when you are continuously boiling, then milk will get spoiled, which is very near to the surface, so it will become charred. So that is why you need stirring, then only you will get uniform heat for the entire, for the all milk. So now that is an engineering principle. How do you supply heat for this vessel is an engineering principle. All these were not there when mother was doing it. She knows how beautifully it can go, and she knows what kind of vessel she has to use. Okay. Normally we never use for boiling of water, for boiling of milk, any mud vessel. No? Mud vessels are there, pots. We never use. Do you use? We use only metal. Why? Heat transfer is good. See, all these things they do not know, but they still do it. That is what is technologists do. So like this now, curd making itself, the engineering automatically comes into when you are thinking on large scale. So now what is engineering then? You have to learn what is heat transfer, how do you supply this heat, what are the equations required. If you want to raise the temperature from room temperature to 100 degrees centigrade or maybe 80 degrees centigrade for milk, how much heat is required, all that calculations will come. Those are all engineering principles. And now you stir it. What kind of stir is required, and how do you stir this? You put people and then make them like this, or you put a motor and motor is connected to the electricity. All that you have to discuss. And when you want to design actual mechanical stirrer, you need again that information. That is why you have to go for again mechanical operations or fluid mechanics, wherever you are taught now this agitation and mixing and agitation. There is a chapter, no? Yeah. So all that is what is engineering. So now we know what is technology and what is engineering. That means engineering means I am not describing in terms of words, but the moment you come to engineering, you have to now use really equations to calculate something, to find something. Okay. And if you are really okay, then science will come. Same example I can tell. Now how much time it takes for curd to finally come? 6 to 7 hours. Now you want to make instantaneous curd. It is not 6 to 7, you do not have patience. In 10 minutes you should have curd. What do you do? What is responsible for curd making? Converting milk into, by the way, is it chemical operation or physical operation? Very good, it is chemical. Why? Because the starting material and the final material both have different properties. Okay, it is okay. So that is why we can end this one as a type of chemical reaction. Okay. So what was the question I was asking? How quickly you can increase the rate of reaction? Earlier it was 8 hours. Now you want only 10 minutes. What do you do? Yeah. One is to find out catalyst. But catalyst for what? Catalyst, where do you put this catalyst? Because we know that microorganisms are responsible for conversion. So do you put catalyst into the microorganism? Yes, you have to put. Really, it is yes, you have to put. How do you put that? Change the genes of that microorganism. That is what is science. That now you are really talking about science. You know now, no? Technology, engineering, and if you want to go for science, now you can go to that microorganisms, look at the microorganisms and then say that okay, now you are taking 8 hours, now I will change you to some super bug, okay, where you can convert the milk into curd in 10 seconds. That is what Hitler tried to do during Second World War. He wanted to change people. Okay? So, he was telling that Aryans are the best people and all that at that time. So, he actually separated the best German boys and best German girls. They have to get married and they have to produce children. Okay, the best breed when he has chosen, now the children automatically will become very, very intelligent. That is what he tried, but unfortunately that experiment was not succeeded. But that is what that means. He did not know at that time gene sequencing all that. Okay, so that is why one of the simplest one is when you get married and then when you have children, what is that you are doing? This nature has chosen all the living beings only to propagate their own species. We are here not to do chemical engineering. Yeah, exactly, really. Okay, and not to do any job. Our job is only to produce children. No, that is what is the realize. The nature of this planet is that. We do not have to be ashamed of that. Otherwise, that species will get extincted. That is all. You take anything which has got life, even trees. One tree, why should it produce thousands of fruits? And within one fruit, again thousands of seeds. What is the reason? Nature wants to maximize every species in its own way to propagate. And if you see really nature, I mean, I really like it. There are different shapes of fruits, right, and different construction of fruits. Tell me, why should we have for coconut that pith and all that that thick shell? Why should we have? Simply not to remove and then break to God. Okay, that only we know for coconut. Okay, it is not actually true, because unless it is changing its density by putting that extra thickness as pith. That thick, the other one comes as pith. That one, how does it change the buoyancy? Because if you take inside shell, the density is different. What will happen if you take coconut after removing all this pith and put in water? Yeah, if it goes down, it cannot propagate its species. So, that is why what it does is, it nature has already constructed that extra pith there, so that it floats and goes from place to place. And most of the time the coconuts, they come wherever there is large amount of water. Large amount of water, I think that beautiful place for them is a large amount of water. Okay. So, then it goes, and then wherever there is a place, and then if it is a good fertile land, it just stays there, and then automatically it will get germinated, and then another coconut will come. So, everything, every fruit, like another thing, cotton. What a wonderful mechanism for that. Now, cotton seed is there, and then the cotton has beautiful fur coming there, and again to buoyancy, to make lighter, so that it floats in air and then goes and falls somewhere, and again it germinates there. And if you see mangroves, there are some trees there, and the shape of those fruits there, it is like a stick, very long stick, like drumsticks what we eat, and you see the drumstick at the end, it is very sharp. And why that sharpness? The same sharpness also is there, this mangroves, where near the seas and all that. So, near seas what will happen is, the what is that flow, tide and low tide and high tide time. Okay. So, there is we have slushiness in the at that place. So, now this once it is ripe, this fruit will simply fall, and the sharpness will just go, and then that will just stick to the slushy mud, and that will germinate there. See, every tree has a wonderful story. So, that is what is the nature's propagation. That is why our job is only to propagate. In fact, we are not listening to nature. That is why we have all the problems. If you listen to the nature, I think the planet will be excellent, no sustainability, because you are designed by nature only for sustainability, because we got intelligence, and our intelligence is spoiling the planet. Really, I tell you, we think that we are very intelligent, and then we create all kinds of materials that create pollution, that changes the constitution of the atmosphere. Okay. So, that is why I think, given a chance, I want to go to that 10 million years before, how people were there, okay, without technology and all that. That is what is sustainable. Okay, anyway, good. So now that is what is the science I was trying to do. I was trying to tell you, if you want to change the genes of this microorganism and then you make them a superbug where its duty is only to convert milk into curd. So like that you take any process, catalyst, by trial and error you found out that you have some catalyst and that is working. But now science will tell you now what kind of surface you need for very good reaction, what kind of orientation of these molecules and how they have to go inside and then sit there and then get converted. In fact, what is happening is the molecules will break into, we have the theory, the molecules will go and get adsorbed, and after adsorption it breaks into different compounds, intermediates, and those intermediates and again come together, and for breaking you need some energy, that is what we say activation energy, right. So if you reduce the activation energy, it will quickly break. So now when you are talking about science, I told that ERTL, okay, I do not know how many of you seen that, he has done that, what kind of surface and surface, what is happening, what is surface phenomena required for catalyst and all that, so that your catalytic reaction must be, earlier it was minutes, now it should be in seconds. So that is what is science. Now I think at least you have an idea what is science, what is technology, and what is technology, what is engineering, and what is science. Science is the highest form where it does not care about the applications, because when you are trying to change the genes, genetic engineering started because of this. You have the bugs already available, nature created them, you take one of those the microorganisms and try to put some other genes there, so that you will become very, very active. That is what I think theoretically we can also be changed. There are many science fiction movies where they do the experiments and then they want to try to make superhuman beings, Superman and all that, then finally they become Frankensteins. Really, I think Frankenstein experiment failed, they want to produce actually the most beautiful person on the intelligent, everything, intelligent person, but finally the experiment failed and then Frankenstein was created. Frankenstein is the devil, very awkward and all that. So that is what is science is the highest form without talking any application. They want to know just okay, how do I change this bug genetically. He never bothers whether it will change the curd or it will change wastewater. Also is a biological wastewater treatment is also by microorganisms, and now biological treatment takes place almost 2 weeks, 3 weeks, 4 weeks. That big ponds what you have, yeah, how do you make them to immediately convert the waste into some product or some neutralize all the waste, so that you can easily discharge, right. So that is where the genetic engineering, that is why science is one where you just have some ideas, okay, how do I make this process very fast and at molecular level, at microorganism level. Then if you apply that to engineering, then you have engineering disciplines. Like now we are applying this catalyst and then trying to produce on large scale through catalytic reactions, ammonia for example, or some other reaction where catalysts are there, or by changing the kinetics, for example SO2 to SO3, SO2 to SO3 is also a catalytic reaction, right. I can use some other molecules or I can use some other catalyst, but when I am doing that in the science level, I do not worry about which operation is really this, we never bother. So that is why highest form is science, application of that to engineering, and now next highest form is in fact is technology. But unfortunately technology can be done without this knowledge, and if you do with this knowledge you get the wonderful technology, excellent technology. One example is planes, aeroplanes. Aeroplane you cannot do by trial and error, you need theory, you need science there. That is what is the wonderful technology, because they are applying science and also they are applying engineering, right. From science they come to engineering, from engineering to technology, and they produce aeroplanes. Okay, I tell you maximum technology is only in aeroplanes, and the next one is electronics. The theory between the theory between application and theory, the real theory, the application is very, very quick. The moment they develop a theory, immediately they can make a product without any time lapse in between. Whereas in mechanical engineering, chemical engineering, civil engineering, it takes minimum to 25 to 50 years. If I develop a new theory in chemical engineering, for example, we are talking about micro reactions, micro reaction engineering. So even now, I think it started almost 75s, almost is 35, around 35 years, but still we do not have ready made plants for that. So theory is different for us, particularly mechanical, chemical and electrical, and even for combustion. For example, when I develop a new theory for combustion, immediately I cannot apply that. It takes time, slowly trial and error, whether it works or not, so much time. But unless in communications, electronics, the moment you have theory, immediately it is applied, satellite is sent. That is, in the two areas, the gap between actual practice and theory is very, very, very less. In fact, medicine also does that. The moment someone finds out some new equipment, immediately that is used on the patients. But chemical engineering, civil engineering, mechanical engineering, metallurgy, you need at least 20 to 50 years time. Okay. So this is what I just wanted to tell, as I know, you have the class. I just close it. I think we will close it tomorrow morning. We will continue.